Owen Wilson and Selma Hayek star in Amazon Studios' mind-bending film Bliss as an unfulfilled man and mysterious woman who believe they are living in a simulated reality and must decide what's real and where they truly belong. This February, chase something real. Amazon Studios' Bliss now streaming on Prime Video. This episode of Star Talk is supported by Progressive Insurance, where customers can save an average of over $750 when they switch and save. Visit Progressive.com to get your car insurance quote. It only takes about 7 minutes. National annual average auto insurance savings by new customers surveyed in 2019. Potential savings will vary.
From the American Museum of Natural History in New York City and beaming out across all of space and time, this is Star Talk, where science and pop culture collide. This is Star Talk. I'm your host, Neil Degrasse Tyson, your personal astrophysicist. And today we're going to have a Cosmic Queries edition of Star Talk with my co-host, Chuck Nice.
Yes.
Chucky, baby.
Hey, Neil.
All right.
What's
Somebody
happening?
slipped in between us here.
That's right.
I got my friend and colleague.
Yes.
Not only professional colleague, but museum colleague, Jackie Faherty.
That's right.
Jackie in the
Hi,
house.
in two houses. Double house
Double
here.
house.
A double house. Jackie is one of the world's experts on the worlds that exist between planets and stars.
Wow.
There's not a sharp boundary there. You might have thought so, or maybe
Right.
you never thought about it. She's thought about it.
Yes.
And she and her peeps. She's got a whole community of people. In fact, after we hired her, she brought other people after she came. So this place, the American Museum of Natural History,
Right.
is one of the intellectual centers of this subject because of this woman right here.
That's correct.
That's
Pump
really
that
cool.
one in. Give me another
Yeah.
one. Right?
I'm going to take ownership of that.
You should.
Yeah. We actually have our research group has stickers and T-shirts and logo. We have a logo, and we made it
Is
out
that the
of
logo with the
subway
the subway
letters.
symbol?
Yeah.
Oh,
Yeah,
really
like
cool.
because our subway symbols in New York City are circles
Yes.
with letters inside of them.
Yes, they are.
So
Yes.
what's your design there?
So we are BD NYC,
Oh,
which stands for Brown Dwarfs,
Right.
in New York City Research Group.
Plus, the B train stops at this
it
institution.
certainly
So
does.
does the C.
That's correct.
B and C. There you go.
So we solicited questions
Yes.
on from our fan base, telling them we're going to have the world's expert on this sort of nether world between planets and stars.
Yes.
And in came hundreds of questions.
Hundreds.
Yes.
Hundreds.
Hundreds of
That's
questions.
Yes.
So you've got them.
And I've got them.
Neither of us have seen it.
No, you haven't.
And
Not
so
that it's a test.
No, I love shows like this when I have one of my astrophysics colleagues, because then I'll have to say a thing.
Right.
She knows everything.
It's,
I'm gonna go get lunch, and then you tell me when you're done.
right. So
I like that. Neil saying I know everything. That's a nice compliment. Thank you, Neil.
yeah. All right. Well, listen, why don't we jump into it with our
Jump in.
first question, which is always from a Patreon patron.
All right.
Okay, here we go. This is AMZ Industries. Wow, we've gone corporate with Patreon patrons.
AMZ.
AMZ
that sounds
Industries.
very New York Stock Exchange listed.
Tell me about
AMZ
it.
Industries.
AMZ, right. AMZ says, the sun is the biggest star in our solar system. I believe it's also the only star in our solar system.
Keep going.
Okay.
Yeah.
Maybe I'm wrong.
We're
I'm
gonna
just
hold
saying.
that one. Yeah.
Okay. Do we know a star or any other object in space or interstellar space that is bigger than our sun? Okay.
Mm.
Okay, so just see, they just mixed galaxy with solar system.
That's what they
all.
did.
That's all.
Thank you.
Yes.
I'm trying to figure this out, but you got it.
Mhm.
Yeah.
That's what they did. So, also to Jackie, do you believe in zodiac signs?
Mhm.
Okay. All
Mhm.
right.
Uh,
So,
Okay, twofold question, both of which are interesting to answer.
And they both
Yes.
sound completely unrelated to each other.
They are unrelated to
Well,
each
I
other,
think-
I believe.
I think one is a genuine interest in the cosmos, and the other is a genuine interest in you.
Oh, I love it. So I will go with the first one is the sun in our, okay, so yes, it's the only star that we know of in our solar system. Although we have searched for another object that might be maybe not a star, but one of these objects I study, a brown dwarf.
Brown dwarf.
That might be a companion to our own sun. Since it's alone, it's by itself. It doesn't have a partner.
So
We have to
are
be
you?
orbiting really far away.
Yeah, I was going to say because you're talking.
Yep.
What I believe we're talking about. Tell me if I'm wrong. is that sometimes there are anomalies in the gravitational movement of objects in our neighborhood, right?
So I think you're going with the Planet 9 explanation.
Okay, that's what
which is and that's also been pulled on and is very popular right now.
Planet 9, not Pluto. Just to be clear.
Yeah.
Right.
Right. Yes.
On this show, we got to be clear about
That's
it.
right.
Okay.
And also, we can discuss why that word planet's not very good in this context anyway.
Right.
So an object outside of what's currently Pluto's position that might be tugging on
Tugging on other
objects in
objects.
the outer part of the solar system. The Kuiper Belt, which is this area of things that are left over from when the solar system formed. And whether or not there's something else that's well beyond that,
Right.
possibly there's indications. Theorists certainly think that. But there was this nemesis hypothesis that existed several years ago,
Okay.
for which that possibly you could link up mass extinctions that happened on this planet with a highly eccentric other object that might have been.
The orbit is eccentric.
Right.
Yes,
Yeah.
Orbit is eccentric.
It's not emotionally eccentric. Right.
It could have been
Right.
emotionally eccentric.
Although it does spend a lot of time alone, so maybe you never know.
Why are we giving emotions to the object? Like, this
Love
is
it.
part of the problem. People put so much emotion on these objects. They want to feel them.
Yeah.
Yeah.
You just call the thing eccentric. That's all.
Yes, eccentric. Right. So, so that it would have an eccentric orbit, and that possibly it was every time it got into some area of the outer solar system, it would kick a bunch of stuff in towards our area and cause possibly mass extinctions.
The comets that would then hit
Yeah.
Earth. Yeah.
Comets, asteroids, and so that's basically, we've looked far and near and we haven't found anything.
Gotcha.
So possibly that's out.
So Nemesis
But-
was the proposed name if such an object existed, and that would have been its name had we found it.
Yeah, and nemesis is the idea that it's our nemesis,
Right.
the Earth's nemesis, not
Right.
necessarily the sun's,
Right.
the Earth's, because if it's gonna
If
basically
it's launching,
bombard
if it's
us-
launching crap at us,
Salvos.
yes,
Exactly. Why would you want that?
Right.
So that would feel like your nemesis,
Yeah,
right?
Sure.
So so beyond that, the question's asking if there's a star that's bigger than our own sun. And that's like, yeah. Definitely.
Right.
There's so many. My favorite star in the nighttime sky is called Eta Carina.
Eta Carina.
You know Eta Carina. Eta Carina's
Love
a
me
beauty.
some Eta Carina.
And I love the fact that it
Beauty.
actually sounds like a pop star. You know what I mean?
Eta?
Yeah.
Eta Carina.
Yeah.
You
Yeah.
know?
It's in the constellation Carina.
They make a good
and-
ice cream flavor.
That Eta
You
Carina.
said, no,
I ate a Carina?
No, Carina is the name of the flavor.
And I ate a Carina.
Yeah.
Wow, I wouldn't have put that in there, but okay. All right.
I like ice cream.
It's in the homunculus nebula. Can you make
There
that
you go.
work as the homunculus
Yeah.
nuts that somehow somebody could make that you'd put on the ice cream? Well, so Eta Carina is a very large star. We now think that it's actually two stars, a binary star system.
Oh.
We call it a luminous blue variable. It's this object that's very, very massive. And so we think it's two, and so 40 to 50 times the mass of our own sun, but probably two of them. They go around each other, eclipsing each other, so that you can actually see the light of one dip very, very periodically.
So that's a variability you were talking about.
Yeah.
Yeah. So
Yeah.
let me just ask you this. Even though it's a body moving in front or transiting another body, how is one slightly larger than the other? Because they're both luminous.
Yeah.
So the idea of a transit is one blocks light from the other, but if they're both glowing, what are you measuring?
So they're not the exact same mass.
Okay.
So you'd have one that's, say, 60 times the mass of a sun, and the other is 30 times the mass
I
of the
got
sun.
you. All right.
There's even some hypothesis that there's a triple system in there. There's three, not just two.
Wow.
So I'm noting Eta Carina because I think it is just an awesome star or star system. But that's not the
good
most
Hubble
massive.
photos of that, right?
Oh, yeah.
Yeah. You check that
Yeah.
out. Yeah, we might put one on the website here. Yeah.
You
Oh, that's
should.
cool.
Because it was part of an HST legacy project.
Hubble Space Telescope. Yeah.
Or, sorry, Hubble Space Telescope.
Yeah.
Yes.
Don't apologize.
Yeah, you're right.
You're in the lingo, girl.
I'm in the lingo.
Do the lingo thing. HST and the elemental P. Right, okay.
Thank you, Neil.
Uh-huh.
And it's a so there's a lot of data on Eta Carina. But it's not the most massive. You get even more massive. There's 100, 200 times the mass of our own sun.
Wow.
And these are not stable systems. These
Again,
stars.
we're not referring to their motions. Chuck.
Right. Right. Exactly.
We have eccentric stars and unstable stars.
I like where this is going.
We also
Yeah.
have degenerate stars as well. That's another thing.
Really?
Yes,
study.
it's an actual kind of star.
Is that okay?
Yeah.
I can't even tell you what. Forget it. My mind immediately went to a star.
And just for
like,
constellation weenies out there, Carina is a constellation visible primarily in the southern hemisphere, and it's part of it's part of a much larger constellation that used to be one piece, and it's the ship of the Argonauts. Okay, Argonavis is the ship, and it's just Carina is the keel, I think.
The keel, yeah.
Yeah. So what they did was that constellation was way too big for its britches, so they broke it up into parts. So there's a compass, there's a sail, there's the hull, there's and so it is the eighth brightest object in the constellation Carina. So Alpha, Beta, Gamma, Delta, Epsilon, Zeta, Eta. So it'll be the seventh brightest star.
And that's important also because it's not always the Eta, because that's what it was cataloged at. But at one time, it was one of the brightest stars in the nighttime sky because the thing is going through massive and insane explosions. And it's just dumping material off, which is creating
that
this
makes the
gorgeous,
beautiful photos.
Yes.
Oh,
the nebula that's around it is so unbelievably attractive to look at. And that's just from
But Chuck,
just
it's really a crime
dumps
scene.
of material.
What's that?
Yeah.
It's really a crime scene.
Right.
You're going to see this gas just spilling out.
so
It's like
good.
something happened down in there.
Yeah, something bad happened.
bad
and
happened.
something is continually bad happening. I mean, I would love to fly close and have a look at that thing. And you wouldn't want to be close as a human because there's probably a lot of
radiation.
really bad radiation
Yeah,
around there.
yeah.
But man, would it be a sight, because it is really pretty
That's very
to
cool.
the human eye.
So Eta Carina.
Yeah.
Nice.
Also, the
Carina.
sun is large enough. If you hollowed it out,
Right.
you could pour 1,000,000 Earths into it.
Our sun.
Our sun.
Right.
And now we're talking about stars bigger than that.
That
That's
right.
all. That's
Much
what I'm saying.
bigger.
That's right.
Much,
And
much,
so
much
these
bigger.
these
yeah.
supermassive stars, these are the ones that become black holes. Like our sun couldn't become a black hole,
No.
could it?
No.
Our sun couldn't become a black hole.
Not
no.
massive enough, but these are the ones, like, you look at these stars, the luminous blue variables, and then there's another kind. They're called Wolf-Rayet stars. So there's actually somebody here.
Wolf-Rayet?
Yes. Yes, actually debatable if it's Wolf-Rayet
Well,
or
these are two
Wolf-Rayet.
people whose
Oh,
original
is that the
research
deal?
paper.
So the people, did they discover this? Or?
Well, they first studied them
Okay.
in an important way.
All right.
And so then realized that no other stars look like those do, so they became their own category.
Nice.
Wolf-Rayet.
Wolf-Rayet.
Rayet.
Okay.
If
Yeah.
it's French, you don't pronounce the trailing consonant.
Right.
I
So
recently-
Wolf-Rayet. Nice. All right. And for the second question,
Reread that, please.
which
All right.
is, do you believe in zodiac signs?
So what I believe is such an interesting thing. There are constellations in the nighttime sky, which are the markers for where the ecliptic of the path that the sun takes in the sky, and all the planets and the moon they take. And so those are designations in the sky, and it's where the sun and the planets and the moon all move. Yeah. I don't place any significance on what people like to do in reading their astrological sign. I'm actually not even sure what my sign is.
Oh, wow. When were you born?
Not totally true. I do know what it is, but I'm,
okay.
I'm just,
But you don't think about it or
I
care
don't
about
think about it
it. Yeah,
too
it's
much.
not a thing.
Right.
Mine is Cancer. I'm a festering malignancy. Thank you.
Does it feel accurate? Oh man.
All right.
All right.
Enough of that.
Thank you, Jackie, for that.
That
All
was
right.
great.
Okay.
Wow.
All right.
I got so much
Chuck,
out of that, man.
What else you got there?
All right. Why don't we this is Sherman from San Diego. Says,
Are we still on the Patreon? Or
This
not?
is a Patreon
Still-
patron.
Okay. Mhm.
Oh.
Sherman from
Hi,
San Diego.
Sherman.
Sherman says, hi, Dr. Tyson, and hi, Dr. Faherty. Understanding that it's only been a few decades since the discovery of the first exoplanets, there is still a lot we don't know about even the closest ones to our solar system. What tools and or resources are needed in the works to help us better understand the nature and composition of these objects? So that's a very good question. Is there anything new and exciting
Can I
that helps us?
pre-pen that question by,
Go
for
by
it.
asking
Yeah.
you, are your methods and tools
Mhm.
to find the worlds between planets and stars, do you have overlap with the methods and tools of those who are finding planets?
Yeah, and I
Interesting.
actually
Yeah.
think this would drive the question of what do we mean when we say the word planet in this particular instance? Because the objects that I study that I get the most excited about studying are ones that we sometimes refer to as rogue worlds, as they are the same mass as the objects that others might want to call a planet. But those objects orbit a star. And the ones that I study don't orbit a star. They're in between. Yeah, they're off there. They're alone. They have no host star.
Homeless.
So there's nothing.
They're homeless.
Yeah, we call them orphan to be nicer, maybe.
Man.
Wow.
Orphan, homeless,
I'm
rogue.
a orphan world.
The orphaned objects that are out there. So that what I do, because it's a lot easier for you to attempt to get to what's in the atmospheres of these objects when they don't have a host star that you have to block the light of, because the contrast ratio is so large.
I never thought about that.
It's so much
Is that
easier.
like seeing a firefly in a Hollywood searchlight? You can't. The brightness contrast is so high. You can't see the dim things. So you got objects where there's no main star, so it's just the object itself.
objects.
Yeah.
Very good.
Just it on its own. But this is where it gets controversial, right? Because it could be the exact same mass, temperature, gravity, the whole deal that we would call an object around another star. But because we find it alone, we call them brown dwarfs. And when they're the lowest mass. So not getting too far down this rabbit hole, which I assume you want me to define what a brown dwarf is at some point.
Yeah, I
guess,
was going to say.
Okay,
Because
all right.
it's probably important for your audience to understand what I'm an expert in.
But just quickly, you're saying that location matters in how you classify such an object.
We don't have a good running definition right now
There it is.
for
Okay.
what it is that we'll call this high mass end problem outside of our own solar system.
High mass planet.
High mass planet. High mass planet or
So what's a brown dwarf?
So brown dwarfs are these objects that exist in mass in between stars and planets, or whatever, the gray area in between. And the idea being that when you form a star, you have a giant molecular cloud of hydrogen and it fragments into pieces. Whatever causes the fragmentation, the compression of the gas, it breaks off into pieces, the smallest possible pieces that could fragment off.
Wait. So you have the main piece, that's the main star.
Well, lots of pieces, right? Like
Okay,
there's
but one of them is going to, the big one's going to be the star. In
there
the middle,
could be hundreds
presumably.
of them that'll be stars.
Oh,
yeah,
of course. All right.
Yeah.
And so now you got the other bits and pieces. Go on.
Yeah, so there'll be a whole spectrum, a whole distribution of objects that will break off out of a gigantic molecular cloud. And this molecular cloud will break down into, once you compress it, so that all of the gas then gets pushed together, and then enough so that the pressure there ignites the cores of these things that break off into tiny pieces. The smallest of the pieces end up being these objects that don't even know that they don't have enough mass to get the core hot enough to get nuclear burning going.
But they do it anyway?
No. No, this is
They
why.
think they're going to be a star, but
they're not.
So whatever. Now you guys are putting emotion on it. They don't know what they should or shouldn't be. They're just existing. And so this is why people called them failed stars.
Right.
Because they're not getting enough mass. But I look at it and like, whatever, dude. Like, who cares? It is existing with not enough mass. That's fine. It doesn't have the mass. Instead, it can't get that nuclear engine going that's at the center of our sun.
Right.
Instead, it's like a coal plucked from a fire. It just cools through its life. And that's it. And that is in between. Basically, what we say is the top mass for that it happens is 75 times the mass of the Jupiter. 75 Jupiters.
That would be a star.
That's
above
the
that is a star.
border,
Yeah,
right?
That's-
Exactly.
okay.
And this is very metallicity dependent, like how much metallicity, how much iron
What's
you have.
metallist? Oh, okay. I got
Yeah,
you.
yeah. Heavy
so
elements.
at the core, like,
Yeah,
okay,
okay.
got
Heavy
you.
elements.
Right.
So how much of that was available will change, like how much mass you need to get the core burning. But then the lower end of it, the low end, I don't know. What's the lowest mass fragment that you can break off? This is a huge discussion in astronomy right now. What is the lowest mass piece that breaks off?
And still becomes a
It
thing.
still
And
becomes
is
a
a thing.
That right.
All right.
That thing that doesn't know what it is.
But then, wait, one last thing on it. One last thing, because I know we have to stop. But the planet would be opposite end of this. Can you form an object, the planets form in a disk around a star, but how big can it get around a star? So now you've got two competing things. You've got objects that form by breaking up a cloud that then self-fragments and blah, 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 blah.
Right.
And then you've got a disk around a forming star, and how big can that object get?
Oh,
Wow.
Okay.
Planet versus
We got to take
brown
a quick
dwarf.
break.
Mm-hmm.
So that's the brown dwarf establishment right
Right.
there.
As
There you
opposed to my brown dwarf, which was the dwarf that was never painted by Disney because he was racist.
Wow.
The eighth dwarf, yes. Chuck has issues. We get him through.
Chuck.
When we come back, more with Jackie Faherty on the worlds between planets and stars on Star Talk.
Wondery's American Innovations presents Mission to Mars. This season explores what advancements have been made and what it will take to send humans to Mars. On July 20th, 1989, President George Bush announced his vision for a manned mission to Mars. Nearly 3 months later, NASA published a complex 30-year plan to get humans to Mars. However, Congress refused to authorize the spending, and NASA's manned mission to Mars was grounded before it could even start. Over 30 years later, the power of government and big business necessary for such an undertaking is finally starting to come together. And now, the next chapter of humankind's space race is on. If you're a Star Talk listener, you know that pushing the boundaries of space exploration is always a compelling story, and Mission to Mars brings that story to life. Listen to Mission to Mars from American Innovations on Apple Podcasts, Stitcher, Spotify, or even 1 week early by joining Wondery Plus in the Wondery app. Wondery. Feel the story. Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches, so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk.
Bringing space and science down to Earth. You're listening to Star Talk.
We're back. Star Talk, Cosmic Queries, the worlds between stars and planets. Where are they? What are they? We got a word for them, but do we understand them? And our best chance of understanding them is this woman right here.
Yes.
Jackie Faherty in the house.
Yes.
Friend and colleague
in
the Department of Astrophysics right here at the American Museum of Natural History. And you just described something I hadn't fully appreciated just before the break, that you have this humongo gas cloud, a molecular cloud, they call them, and it'll break into bits. And these are typically stars, but some might not be stars. In addition to that, each one of these will have a disk of material surrounding it that will then break up into little bits beyond the bits that just broke off to make the thing that had the disk.
Mm-hmm.
Did I understand that?
You're doing good. Yeah,
I'm
yeah.
doing okay.
I will say, right. So those are
two different kinds of phenomenon going on.
two different formation mechanisms.
That's the phrase I'm looking for.
Right. And so we want to use that as definitional for saying, like, what kind of object are you looking at? I'd prefer to know how it formed because can you eject these objects that form around a star?
Yeah, you do.
Oh,
Often.
100% you do.
Yeah.
They're launched off. We ejected stuff all sorts of ways. When
we might have had like 30
formed
planets or something at that
yes,
beginning.
Right?
Yes, exactly.
And now we're down to 8. Get over it. And so all would be rogue planets by now.
Rogue worlds.
Or eaten.
Rogue worlds. I like rogue worlds rather than planets.
Rogue
just
worlds.
'cause
Or could have any of them join forces to become like
get picked up by another star.
get picked up by another star.
Yeah, so we talk about that too. That's pretty hard to do, but not impossible.
Okay.
It's possible that it could happen. They get scattered around. And we have evidence for this material now. Like present day, we have material that has passed through our own solar system after it probably got ejected from a totally different solar system.
Nice.
This object called Oumuamua, which is a interstellar asteroid rock that came flying through here. And that probably got dumped out when its own sun was forming its solar system. So the one thing on this,
That ain't right.
I know.
Yeah. It is okay. Like
Don't let the doorknob hit you, Oumuamua.
But don't you think?
Oumuamua, by the way, is Hawaiian for scout, and it's repeated Oumuamua for emphasis. So
Gotcha.
it's basically first scout.
Gotcha.
If you would.
Right.
And it was named that because it was on it was found through a telescope in Hawaii, the Pan-STARRS telescope, which is a wonderful telescope. And as an homage to Hawaii, they chose this wonderful
Hawaiian language.
name.
Yeah.
Right.
So just I did this calculation long ago. This is the perfect time for me to invoke it.
All right.
Because how often does one
Let's
get
hear
to
it.
invoke a calculation?
Sweet.
If there were 4 bumblebees flying in the continental United States,
Okay.
the chances of them accidentally bumping into each other are greater than any 2 stars in our galaxy.
Ooh.
Wow.
So,
Wait.
but if you want to talk about how empty space is between
that's how much
stars,
stuff is not there.
it's not there.
for them to
so
hit.
if you have rogue things cast off, there's still the unlikelihood that you would even come into the vicinity of another star. But even if you did, you're going to have a velocity that's hard to trap.
Suppose
So Oumuamua had hyperbolic velocity, so we're not.
Right.
It's coming through.
it's coming through.
It's not
and
even looking
like,
back.
Right.
No,
Right.
it has
It's
nothing to do with us.
gangbusters.
Right. Like we didn't
Yeah.
capture it. We're not doing anything.
We're not doing
with
a
it.
damn thing to it.
It came through like beep, beep, here I come, there I go. And even looking at its motion, its velocity,
Yeah.
it looked like maybe we were its first pass.
Yeah.
Possibly. This is very hard to tease out, but there was a paper on that, whether or not we were the
A
first.
research paper. Yeah.
A research paper that was looking at whether or not we were its first encounter after
Right.
it departed. And astronomers tried to trace it back and see where it might have come
Right.
from.
Right. So now, with that in mind, we're the first pass? Did we alter its course?
Oh, great question.
Yeah.
Chuck. I don't know. Maybe.
Well, yeah,
Probably
yeah.
a little bit.
Oh yeah. Oh, it feels.
Yeah.
You can not get captured, but still feel what's going on here.
Okay.
Oh yeah. So if you look at, they have the trajectory.
Oh, yeah.
And the trajectory is arc.
Right.
In
Okay.
response to the gravity of Jupiter and the sun.
Interesting.
But when you put
Primarily Jupiter and
enough of a change in the velocity that when it gets to the next star, it's really obvious. Like, oh, this is its next stellar encounter. I'm not sure we can tease it out quite yet because it still looks like a disk. It's like a disk object, just sort of flying around in the disk of the Milky Way.
Nice.
Beep, beep.
What's that? The
Road
Jetsons.
No,
The Jetsons.
Oh, flying the flying cars.
Yeah.
Oh,
Jetsons,
I thought you were doing beep, beep from the
It's
Roadrunner.
before your time. Sorry.
Maybe.
She's like, okay.
Okay.
Yeah, Jetsons were so before
take it.
everybody's time. Yeah.
I watched it when I was a kid, so I don't know why it's before.
The Roadrunner did a beep beep too.
Yes, he did.
Yeah.
You know, I just learned recently, but this had nothing to do with anything. The Roadrunner never left the road.
How about when he was standing on air and the coyote would fall?
No, the coyote's standing on air. The Roadrunner
Oh,
isn't.
That's true.
Oh. Huh.
Interesting.
Yeah, the Roadrunner
Okay.
stops before it gets to the edge of the cliff, and it's always on the road.
That's interesting.
Hence, the Roadrunner.
Yeah. I have another point on stellar flyby. I wanted to just pull us back in here, Neil. So you might
You like my pop culture references? I'm
I
sorry.
do. I love it. I love it.
Okay.
I love it. I love it. It's so great. But one of the things that I think is massively interesting right now in astronomy is how many times stars not run into each other, but interact with one another. So the issue of, and this is my new thing, I'm really into the new villain of planetary architecture, is the stellar flyby. The unappreciated influence that stars that move by each other can have. And the reason why I say that in
Fly-by
part,
looting.
flybys that will change change the structure of maybe your planetary system, or now, like, okay, so the question I think had something to do with what we're understanding about exoplanets and learning about it in the future. So here's one for everybody. In 1 million years, just about 1 million, it's like 1.1 million years.
Okay.
Let me put that on my.
Put
On
the
the calendar.
I don't.
Put it on
I
the
can't give you the
calendar.
October
exact
12th.
date.
October
well,
12th,
you know,
1 million years.
plus or minus like 10,000 years. Yes, but there will be a stellar flyby, so at its closest encounter, by a star that's smaller than our own sun, but we're headed for each other. And in 1 million years, it's going to pass within our Oort cloud. It's coming straight in.
So the Oort cloud, the outer region of comets, that's a spherical zone. Very distant, but very there.
Very there.
Very
with
there.
lots of material.
Yeah, this is like trillions of comets just
Okay, that
just
sounds,
waiting to strike.
I was going to say that sounds catastrophic.
We've looked at it.
Yeah.
Astronomers have looked at it to see, like, is it going to be a disaster? And the conclusion is it's uncertain, but the impact that it'll have on the Oort cloud might not be super bad.
Jan Oort was the Dutch astronomer who first calculated the existence of the Oort cloud. It's so far away you can't see the objects at that distance, but when they come in, you see them near the sun and you look at their trajectory. And you say, oh, this
You
much
trace them right
terminate way out at this distance before it comes back again.
The calls are coming from inside the house. Okay.
But
That's good.
so if you think about it, the Oort cloud actually stretches a third of the way to the closest star. A third of the way.
Wow.
It gets loose. So, I mean, think about that. You get something that flies between us and that next closest object. It loosens up things.
Because they've only barely held on to begin with. So
Barely
any
held on.
disturbance will completely wreak havoc.
And most important here is the consideration of we're constantly doing mission planning. Like, what are the next stages of mission planning, right?
And what's the name of the star? Just so I know.
So it's the Gliese 780.
Okay.
It's one of these names that I constantly mix it with 780 versus 781, I think. So that's my fear of
As
saying
do
the
we all.
incorrect one.
Gleason,
Gleason.
7.
No,
Not Gleason?
Gleason. G-L-E-I-S-E?
E-S.
Gleason.
G-L-I-E-S-E.
E-S-E. It's a catalog of it's fast-moving stars, right?
Close, bright, so they're mostly fast-moving.
Yeah, yeah. Fast-moving in our field of view. So in order for that to be the case, they have to be nearby. So
Man, I was hoping it was Gleason.
no.
No,
That would be
unfortunately.
But just to be
no,
clear,
no,
Norton.
No.
So this is not a catalog of stars that are actually moving fast. It's a catalog of stars that are moving fast in our field of view. So you can have a bird fly by in front of you, and that's going maybe 20 miles an hour, and a plane that's moving past your field of view much more slowly.
Right.
And you're not going to say
That the bird is going faster than the plane.
The bird's not going 600 miles an hour.
Right.
Right. So that angle matters, and that angle it manifests by its distance. So there's a catalog of selected for their fast movement in our night sky, and those tend to be the nearest objects.
Yeah,
so you
right,
got
because we're
nearby
detecting them.
objects.
And so that one had been known. We've known about that star for a really long time. It's a very bright star, and it's
headed for us.
we are headed for it. It's heading
headed
for us. And just think about it. It's probably got a solar system around it, and an Oort cloud, and a
not?
Kuiper belt. Why not?
Why wouldn't
They're
it?
probably the majority of stars. Why wouldn't
Why
they
wouldn't
have
they?
them?
Wow.
And so when I've got all of my, every time I give a
Are
science
you
talk,
ready
I
to
bring
wave
this
as
up.
they come?
But don't you want to? We're going to see it.
Totally
want
wanna get in it.
Like people on a
bring
boat.
it here.
Wait, that means our
Let's-
Oort clouds will intersect.
More than that, yes. The Oort clouds, the Kuiper belts, possibly like whatever this thing's got around it, we could fly something to it. There's a lot of this discussion about going to Proxima Centauri because we all want to get there like now.
The nearest
while we're all
star to the
still
sun.
alive.
Yeah. Mm-hmm.
Gliese 780, man. Let's go.
That's
Let's
going to be
do
even
it.
closer when it's close.
Right.
It's going to be so close.
She sounds like she's like ready to.
I was
going
going
to
to say,
for it.
and I am so ready to do this 1 million years from now.
She's talking like she got her telescope all
I
ready
know.
for it.
This is very sad because
Yeah,
I'll be
you better
dead.
take them longevity pills before that happens.
No, by then we'll be able to upload your consciousness to a computer.
That'll
so
be
you'll
so
still be
nice.
around.
That's good.
Yeah.
I'd like to see it when it happens.
Cool.
Chuck, what else you got?
All right. So, okay. Let's go for a quick one because I know we're running out of time in this segment. This is from Rossi King.
You could do a long one and then I tease the next segment, dude. This is how I do this.
Well, if we keep discussing this like this, we'll be able to do it with this short one.
All right, go.
No, this is Rossi King from YouTube. Actually, I just wanted to ask this for myself, too. Was Jupiter a failed star? And then the person says, I'm really glad it failed because I love it in the nighttime sky.
Oh, very nice.
How cute is that?
That should be a quick answer.
Yeah, but it's Jupiter and field star, which, yeah.
Yeah. No, it's not. No, the quick answer to that would be no. But again, let's not call them failed stars. Let's just call them
Achieving planets.
I call them overexcited planets. Thank you.
Overachieving planets?
I'm not kidding, Neil. This
That's
is my coined
hilarious.
term.
This is very modern teacher lingo,
Yes.
right? For
Overexcited planets. That's what I sometimes call them, but then I don't like
Don't
planets.
star shame me. Don't star shame
Love it.
me.
You guys are
I
going
am
with it.
not
Exactly.
a failed star.
Exactly. Jupiter shouldn't feel in any way, shape, or form like it is.
Inadequate.
Exactly.
Right.
It is a behemoth of our solar system.
Yes.
Many times I say, if I'm going to find an Earth-like planet that I'll be comfortable saying, yes, let's consider that habitable, I want a Jupiter at a Jupiter radius away, because you know what Jupiter does for us? It protects us in a lot of ways.
Okay.
It's the bouncer of the solar system.
Yeah.
It's the one that's like taken hits for us because asteroids get dumped in and comets are coming in. And what does Jupiter do? It takes a lot of hits. Sure, it deflects some of them our way.
Mm-hmm.
Let's not talk about that part.
Right.
But unless you want to, but I would
ID,
say
please.
but most of what it does is protect.
Is
It
protect
shields
it's a
us. Yeah.
protector. So
Right.
I'd
Yeah.
really like to see if we
I
find
like
an
the
object.
bouncer of the solar system.
ID, please.
Standing out there. ID,
Exactly.
please.
Right. That's what it says to all the comments as they come in. Like, nope.
What?
ID
That's cool.
includes what your trajectory is.
Yeah,
right.
there you go.
It's trajectory, please.
Right.
Right.
Yeah.
No, that ain't happening. Keep walking. So.
So I would not call it a failed star. I'd call it the bouncer of the solar system. The most
Nice.
important of the planets for Earth to consider right now.
So how much more mass would it need for it to have ignited a core of energy?
Or not even a core, for it to not have ignited a core of energy
Well, this
and
is
become the overachieving planet.
right. So the brown dwarf regime is roughly the lower mass bound that we call is about 13 times the mass of Jupiter, but that not a great number. That was a traditional number that
So
was
about a
used.
factor of 10.
And right, and the reason is because at that mass you can get heavy hydrogen burning or
Okay.
deuterium burning,
Mhm.
and so because that tended to be a definitional thing where either the difference between a star and a brown dwarf is hydrogen burning, nuclear burning, and then it was kind of capped at the bottom end of like, well, at about 13 Jupiter masses, then it's deuterium burning that stops. And so, boom, that was the definition, and it's terrible.
So the way to think about it is just if Jupiter had more than 10 times its current mass, it would start entering the brown dwarf regime.
Yeah, it would be a massive
Okay.
thing.
But something about Jupiter, however, that just Jupiter would be proud, I think, is that it is emitting more energy than it is receiving from the sun.
Yes.
So it is a net energy generating object in this solar
It's
system.
like a blue state. Sorry, that was very political of me.
It was.
I'll fill in those details after this break when Star Talk continues. The world between planets and stars.
You know you're ready to earn your degree, but you need a university that works with your busy schedule. At WGU, their programs were built to be flexible. WGU offers a quality degree program that's affordable, flexible, and even makes it possible to graduate faster. You can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. What? What year is this? See what WGU's competency-based programs can offer you. There are no set login times and 24/7 access to most coursework, so that means you can earn your respective bachelor's or master's degree on your own time. WGU's low flat rate tuition covers as many courses as you can complete each term. That means you can use what you have to get what you want. Take your skills and use them to graduate faster. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee waived. Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Joe Aguirre, or maybe Joe pronounces it Aguirre, Daniel Hargrove, and Jill Berkey. Guys, thanks so much for your support of Star Talk through Patreon, because without you, it'd be a lot more difficult to make this show. And if you would like to have your name shouted out as a Patreon patron, please go to patreon.com/StarTalkRadio and support us.
Bringing space and science down to Earth. You're listening to Star Talk.
We're back on Star Talk. Cosmic Queries, the worlds between planets and stars. And we have one of the world's experts on that, Jackie Faherty. Mm-hmm. One of my colleagues. She's my colleague.
Right,
So
yes.
you know.
Well, while I'm sitting here, I can be her colleague while I'm here. Yes, exactly. Just,
No, we get comedians here, they're your colleagues. If I get one of my people, she's my colleague.
somehow I lose in this deal.
So we were talking about Jupiter as not a failed star, but an overachieving planet. But still, it's a factor of 10 in mass away from having turned on as a star. So that's still kind of far away. It's not kissing the door, kissing the boundary there, right? Factor of 10.
No, yeah. It's in squarely in the we're totally comfortable calling it a planet object.
Right.
It'd have to be quite a bit more massive before we start to feel awkward. There are other systems. There's one called HR 8799. It's the name of the star. And it has...
Again, name for the catalog out of which they come. Yeah. Mm-hmm.
Right. And these stars also have multiple names, but that's the most popular of the names. I often call that system...
Because that's the catchiest name.
HR 799.
That's the most popular.
That's
that one just rolls off the tongue.
Yeah,
Rolls
that's
off
like the
tongue.
share of the...
HR 8799. So I sometimes call HR 8799 the Brad Pitt of planetary systems that have been directly imaged. Because if you have a camera, aka a coronagraph or an adaptive optics system for astronomy,
Special camera for this, yeah.
Yeah, we point it at HR 8799 because it's so pretty.
Nice.
The system. And you can image 4 planets orbiting
In one fell swoop.
Yeah, and I would highly recommend for your listeners.
Does Brad Pitt know this?
I have said it so much, I hope so.
Okay.
And that
All
I'd
right.
like him to just feel like the honor of the Brad Pitt status of planetary systems. HR 799, he could just call himself the HR 8799 of
Hollywood.
celebrities.
Of Hollywood.
I'm Hollywood's
Switch
HR
it up.
8799, baby.
Switch it up.
Just so you know,
Right.
just so
Point a camera at me.
So the year I was the sexiest astrophysicist alive.
Okay.
This is 40 pounds ago, by the way.
I love that we are now measuring chronology in pounds.
That
That's
year,
great.
Pretty
Brad
good.
Pitt was the cover as sexiest man alive.
Cute.
Beyond category.
Nice.
So me to had to be in a category,
Right.
in order to but he had no category.
What year is this?
I
I want to link it to HR 8799.
Next time, next question.
Don't want to
Oh,
answer
that was
it.
Next
great.
question.
All right. So I have a question personally that I'm thinking now, and I can't stop thinking about it. As you were talking about these formation mechanisms, what I want to know is it possible to have those two formation mechanisms happen simultaneously? So, I'm sorry, the 3 formation mechanisms happen simultaneously so that you have that star that's being surrounded by a brown dwarf and planets.
Yes.
Can that happen?
So you're asking a question that basically got asked at a seminar the other day. I ask it all the time. And the result would be, is it possible that you can form a brown dwarf?
Yeah.
What this thing is that we call a brown dwarf, these objects that have deuterium burning and they're formed through the process of fragmentation of a giant molecular cloud. And you can make that same kind of object, deuterium burning, through the accretion process or gravitational fragmentation around a star.
Right.
And so, can you get, if you're going to count up all the objects, you would see at a certain mass, you would start to get more of the object because you're forming them 2 different ways. And so you would see a higher number of objects popping out as you get down to like, maybe it's at 10 Jupiter masses, maybe it's at 12, maybe it's at 4, whatever it is, because you're doubling down on how you form
On the
them.
mechanism.
Yes,
Wow,
you would
okay.
double the number, double, maybe triple, maybe quadruple, or maybe just a little bit more. But we're looking for this exact thing, for counting up the numbers we get and then
Okay,
seeing
Chuck,
if
you're her
there's any
colleague now.
signature.
I take
like-
it back. I take it back.
Pretty good. Pretty good.
Well,
yes.
thanks.
Yes,
Yeah.
100%. This
All
is
right, cool.
I
cool,
take it
cool.
back, Chuck.
important.
Excellent. No, you know.
So, Chuck, this is our final segment. We got to go into like lightning round now.
All right, let's move into our lightning round.
That was a bell.
Okay.
Go, Chuck.
Well, this is such a fascinating
So, Jackie,
subject
your
matter.
answer has to be
How
a
many
soundbite.
seconds?
We're testing your sound bititude.
Got it.
Okay?
Ready.
All right, go, Chuck.
Okay. This is Kristen Davies. And Kristen says, I'm a 7th grade science teacher in Ohio, and I ask my students for their questions on the topic today. My students and I enjoy listening to clean episodes of Star Talk. Okay. Now you see why I'm reading
Episodes
this? Okay.
that don't have Chuck in
Yeah,
them.
that's what I'm saying. Thanks a lot, Kristen. Yeah, but I'm the one reading your question, Kristen. Just remember that. During our study times, I listen to other episodes on my commute to work, and that gets me pumped up. So here's what she says. From the student, how many stars are in the universe? Has anyone ever counted them, and is it possible? Another student says, can you turn a planet into a star? 1 and 2 questions.
Okay, first question, go.
All right. So, number of stars in the universe.
Universe.
That number is insane. Number of stars in the galaxy, we're going to go with 200 billion probably. And so then there's billions and billions of galaxies.
Right.
That's why I'm
So there you
saying
go.
too large for me to give the exact number. Second question, can you turn a planet into
Into
a
a star.
Awesome question. People are trying to figure this out. Unlikely, because you dump enough material onto it, it probably gets fatter and you probably can't ignite
Right,
unless you do a gigantic dump from something that happened.
Fantastic.
But we can do a quick, Jackie, we can do the calculation.
Yeah.
If for the number of stars, if you just say our galaxy has like 100 billion stars, let's say.
200.
And-
Let's
and-
go with 200 billion.
Well, just factor 2 between friends. Come
Yeah,
on
yeah,
now, it's
sure,
not a thing.
okay.
So, and to keep the math simple, 100 billion stars.
Okay.
And there's somewhere between 10 and 100 billion galaxies in the observable universe. So 100 billion times 100 billion, that's 10 to the 21st power.
Okay. There you go.
What do you call that?
That's 1 sextillion.
Sextillion.
That's
Yeah.
a sextillion?
Sextillion.
That seems very small.
Well, let's do it. So a billion is, stay with me, 9 zeros is a billion.
Right.
Trillion,
Okay.
count the zeros, it's 12.
10, right?
12.
Okay.
Units, 3 zeros at a time.
Because
Okay?
it would have been 100 billion. I know.
Start again.
Orders of
Okay.
magnitude.
So 12 trillion.
It's a trillion. 15, quadrillion.
Quadrillion.
18, quintillion.
Quin.
21,
Sex.
sextillion.
hmm
Right.
So that's all I'm saying.
Yeah.
Yeah, so about sextillion.
No, but I'm
stars.
saying
I'm
when I
with
say
you.
that seems small, I mean it seems small. for the-
Sextillion is small to you?
Yeah.
No. Plus,
I mean, it's big. That's a
plus
number
if you-
I don't say because it's just
It's
so
just too crazy big.
No,
I
I'm
agree
talking
with
about.
Jackie.
I'm talking about when you from where we're starting. I think because you said it's only 100 billion.
In our own galaxy.
in our galaxy.
Yeah.
Oh, okay. All right. Forget it then.
Right.
Plus, if there's not a sextillion stars together, then there's 2 sextillion.
Right.
Yeah.
These at those numbers, these factors
They
of
don't
1
make
and
a
2,
difference. They
you
make
want
no
to get the
difference.
sense of the
Right.
scale
Right.
of this more than
But you
wanna-
still can't get the sense
But
of that.
one other thing.
And not
to-
all galaxies are our size. There's a
No,
lot of
there's
small
ones,
and
there's
big ones.
bigger
Yeah.
ones. There's collide galaxies that have merged and come
Yeah.
together. But another thing they asked about counting the number of stars, and there is this survey called it's a European survey. It's called Gaia, and counting. So they're called the Billion Star Survey. 1.7 billion stars, and that's
And
huge.
Those are not extrapolated. They're
Right.
actually counting.
counted.
They've counted a billion
measure their
stars.
distances, how far away they are. It's the greatest map that humans have ever produced. of
1.7 billion
billion. Right.
objects in a catalog.
That's
Right.
like a drop the mic moment.
Yeah,
I
that's
can't
pretty
do
cool.
that here. Okay,
Did
you
Oh,
did.
Okay, he did it. I was going to say, please don't let that hit the ground.
Neil dropped the mic for Gaia.
Excellent. Next.
Okay.
Keep it moving. Oh, wait. Go.
There we go. All right. This is from Twitter, and this is Akshat says this. I think that's the name. Whatever. Who cares? How do astronomers study?
Akshat cares.
Akshat probably cares. How do astronomers study the atmospheres of brown dwarfs,
Ooh.
and how do we even detect them?
Yeah,
So-
that's
Yeah.
exactly what I do for a living.
Yeah.
And the way that we detect it is directly. So that's the actual method
Let's
that we
pause
call
for a
it.
moment.
Mm.
That you can do that for a living.
Yeah.
I know.
Isn't that
That's a
just,
great
just,
thing to
just
say.
Reflect just
Yeah.
a moment. Just a moment.
Oh.
Oh, let's all hold hands.
Okay.
Yes.
Meditative moment.
Yes.
Okay,
felt-
Jackie.
It is a
felt right.
wonderful thing that you can do that for a living.
Yeah.
Okay, go.
Yeah. I also say the tagline for astronomers, though, is unlocking the secrets of the universe for a living. Like, that's a good tagline, right? You
Right.
know? I mean, sure, studying the atmospheres of brown dwarfs sounds good, too, but unlocking the secrets of the universe.
Okay, remember, we're in lightning round.
I know,
so go.
sorry. Direct imaging is the technique that we use.
Okay.
And I basically take a telescope, I point it directly at the object.
Oh.
For the most part, I have to use infrared instruments, though.
Okay.
So a wavelength of light that you can't see with your eye, a wavelength that's a bit longer than the radiation that we all give off, the heat that we give off. And I'll take it and I'll take the light, I pass it through a spectrograph, and I look at what it's made. What is the chemical composition? What kinds of lines do I see? And mostly it's molecular features.
Molecules.
Very cool.
Molecules.
Yeah, okay. All right, cool.
All right, excellent.
Mhm.
Let's
Yeah.
move. There we go. Let's
Keep it
go. This is Tom Cat. Thank you, Tom. Tom Cat wants to know this: do brown dwarfs have surfaces, or are they just balls of hot gas?
Go.
Yeah,
Nice.
we're often asked this, and there's no surface for you to stand on. Similar with Jupiter and Saturn,
right.
you're not going there and standing and having a really nice time.
No, yeah.
No, we
That's why they
study
call them gas giants.
Yeah,
right?
gas giants, and so brown dwarfs are souped up gas giants.
Okay.
Very similar.
So there's
to
no
Jupiter.
point deep enough where it's dense enough that you can call it a surface?
There might be. We don't know.
You just don't want to go. You don't,
We're-
you don't want to test it.
You'll die. We all die, right? But
That's hilarious.
could they have some sort of core similar to Jupiter or Saturn,
Mm-hmm.
which would have some sort of core? Very well, it could have that. We don't know yet, though.
All right, good.
Excellent. This is Luigi Vanni. Luigi Vanni says this: how do we know what a planet is made of and if it has an atmosphere, if it goes by how much light passes through or by it?
So that sounds like they're asking about the transit method.
Pretty much.
One of the ways that we detect planets is by looking at the planet pass in front of its host star, between your eyeball and that host star. And there's lots of methods that astronomers have developed to look at the light of the star very, very carefully and see if there's any change in it as they are suspecting the transit is happening. You have to have the timing down, like smack down, to when that transit is happening. You look right at the star and you can see what it's made of. This is very complicated.
You see what the atmosphere of the planet, the transiting planet, is made of.
Right.
Right.
Through the light of the host star.
Mhm.
It's a very complicated method. My preference, just to re-gauge us back to brown dwarfs, is we draw upon what we do in brown dwarf science. Since we directly detect the atmospheres, we can guide any measurements that you want to make when you're trying to make detections of
Oh, so
objects.
you have ground truth of
We-
what the atmosphere might
Exactly.
be for those who are looking for the transit in front of a much brighter star in the background.
We are
Okay.
ground truth for transiting planets, especially hot Jupiters, these objects that are pretty close in that are like Jupiter.
Cool. All right. Here we go.
Damn.
Actually, I think we just ran out of time.
Did we really?
We ran out of time.
Oh,
yeah,
man.
yeah, Chuck. I'm sorry
okay.
about that.
All right.
That's sad.
that
Oh,
is sad.
so many
You
questions.
know what I think we should have? We should have put a few of those online and have Jackie answer them.
Oh, that's a good idea.
What do you
could
think
do
of
that.
Yeah.
We'll put in for that. I'll
It's
check with our
amazing. I mean,
producers.
people really
People
are
go all
excited
into it.
about brown dwarfs, man.
into what you get paid
Yeah,
for.
they really
Yeah,
are.
get paid to do this for a living.
Yeah,
It's a pretty good job. Pretty good job.
All right, Jackie, thanks for being on Star Toys. It's not your first rodeo with us, and so
no,
thanks
well,
for being on.
I've done All Stars with Chuck, but this is the first time we've ever
Is it our
done
first
one.
time? Oh,
It
we
is
gotta do this
our
more
first
often.
time. Neil.
Yeah. Oh, so you go way back.
Yeah,
too.
I'm the HR 80. I'm the HR
799
Yeah.
of co-host.
All right, this brings this episode of Star Talk to a close. I thank my co-host Chuck Nice,
Always a
my
pleasure.
friend and colleague Jackie Faherty. Thanks for coming on, and as always, I bid you to keep looking up.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, it's not, nope, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. Poof, gone, waived.